Hello everyone. So now we will solve the second problem of this contest. The problem goes by the name sum of prime numbers between number and its reverse. So what is the problem? This problem is marked as medium, but it is the easy one if you understand how to solve, right? So the problem goes that you are given an integer n. Let r be the integer formed by reversing the digits of n. We need to return the sum of all prime numbers between minimum of n to r and maximum of n to r inclusive, right? So a prime number is a natural number greater than 1 with only two factors, 1 and itself, right? So first let's understand what is a prime number, right? I hope you know what are the prime numbers, like 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number, and so on, right? Now, why are these the prime numbers? Because these numbers are divisible by itself and 1, right? You won't find any factor except 1 and 2 for this. You won't find any factor except 1 and 3 for this. You won't find any factor except for 1 and 11, right? So this is the prime number, right? So what they are saying is we will have an integer n and r be the integer which will be formed by reversing the digits of n, right? So let's say if my r was 13 in the first test case, so what will the reverse integer be? Simply convert it into a string, call it 13, right? And then reverse it. After reversing it becomes 31, but in the form of string, right? Now again come back into integer, it becomes 31, right? So by this way you can convert the string, convert the integer back to the reverse integer, right? So this is one way. There are multiple ways to do it, but I have done in this way. So you will be given an n, right? Sorry, and this is your r, which is the reverse of the initial integer which was given to you, right? I hope things are making sense. So if n was 13, so let's see, the end point was, starting point was 13, right? The ending point or the r was 31, right? So let's see how many integers are there in between 13 and 31 which are prime. 13 is a prime, 17 will be a prime, 19 will be a prime, 23 will be a prime, 29 will be a prime, and 31 itself will be a prime. So there will be 3 and 3, 6 integers which will be prime, right? So 13, 17, 19, 23, 29, and 31. And if you do a sum of all the elements, the sum is 132, and you need to return that at in, right? Let's look at the time constraints. The time constraints given to you was 1000, right? So n is 183, right? So you can write any solution. Your root solution will also work, right? You can convert every time, you can find all the numbers from n to reverse of n, right? And it will still get accepted, right? But that is not the correct way, right? If you are doing like LeetCode, then you should try to write the optimalist solution that you can think of, right? Not just the brute solution. In contest, you might get accepted a few problems, but you should further push to think what can be the most optimal solution that you can write, right? Because if you try to generate all prime numbers, right, every time, then it will be, even if you use sieve of parenthesis, it will take big O of n log of n, right? So let's say if your n was, in this case it is 1e3, right? So this will almost get accepted. It will get accepted every time, right? Because of the smaller constraints. But let's say your constraints were tight, then you need to be a bit smart, right? What we can do is, instead of computing it, instead of finding n every time, what we can do is we can pre-compute the n, the prime numbers, right? Pre-compute the prime numbers, right? Now what we will do is we will use the sieve of parenthesis. If you don't know, wait for the end. I will explain the sieve of parenthesis at the end of the video so that the flow doesn't break, right? So what we will do, we will create a prime vector, right? That will store that is the given number prime or not, right? If I am standing at this position, I will ask, is this number a prime number or not, right? Is this number a prime number or not? And I will store in the form of true, true, false, false, right? So I will have an idea, or rather 1 0 1 0 1 0, something like this, right? uh, yeah. So I will have that, okay, these numbers are prime, right? Now what we will do after that, let's say we had 1, which is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number, and let's say 5 is a prime number, right? Let's say not, it is a prime number, right? So this was my prime splitter, right? Now I will say, okay, I am creating a prime sum, right? What is this prime sum? This will store the sum of all the elements till that very index, right? Let's say I had a 6 as well, 6 is not a prime. So what will this do? This will say, okay, prime sum of 1 will be 0, prime sum of 2 will be, as this is true, we will say store the value as it is, means will be 2, right? It is true as well, so this will be 2 plus 3, which is 5. This is 0, so you will store the initial, means the back sum, right? 5 means if anyone comes, I will show why we are storing as it is sum. In this place we stored 2 plus 3, right? This came as 0 plus 2, this came as 2 plus 3, this came as it is 5. This is again a prime, this is 10, this is not a prime, 10, right? Now let's say someone comes in future and asks you, okay, you tell me what is the sum of all the prime numbers between, let's say, 3 and 6, right? Let's see and test and how see how does it run, right? So prime number between 3 and 6 inclusive, right, means you need to include them as well. So these are 3 and 5, right? So sum should be 8, right? So what you will do is you will stand at the ending position. You will say, okay, prime sum of ending position. What is the ending position? 6 minus prime sum of starting position, which is 3, right? So you will say prime sum of, if you go to 3 now, you will see that, okay, you are including that number as your prime number, right? So you might miss one number, right? If you do, like if you did minus 10 5, then that will give you a wrong value, right? So you need to do a start minus 1. This is the core concept of prime sum, right? Or not prime sum, prefix sum, right? So you will say, okay, 3 minus 1, whatever value is there, I will do a minus 1 to it, right? So prime sum of 6, if you look at that, is 10, and prime sum of 3 minus 1, which is 2, which is 2 itself. So you will say 10 minus 2, which is 8, right? So you saw how we did any given number, right? If you are given any given number, you just need to do a p sum minus 1, right? And that's it, you will get the correct sum in big O of 1, right? Did we do any other operations instead of, like, we pre-computed everything, right? After pre-computation we did not do anything, right? So the ultimate time complexity will be big O of 1 for any queries, right? They might see, don't think of a stiffness in the problem, right? See, in a longer run, that if we were given, let's say, n queries, right? If you're given n queries, would you able to use the brute force cell? Absolutely not, right? So in that case, you need to pre-compute it. That's the reason why I'm trying to teach you why should you think of a better or optimized solution, right? So in this way, you can easily find any solution in big of 1, right? If you pre-compute it, and after that you can simply find the big of 1, right? uh, if you want, I can show a smaller test case, because these test cases are large, right? Let's look at this one till n equal to 10. That will be a better one, right? So we saw that 1 2 3 4 5 6 7 8 9 10. All right, let me quickly draw it, right? Till then, if you have not subscribed, please do subscribe, right? We saw that sum was 2, we saw 5, we saw 5, we saw 10. 10, this is a prime number, it will get added 17. This is not a prime number, 9 is not a prime number, and 10 is not a prime number, right? So now the problem is from n 10 to, if you reverse it, right? So n was initial point is 10, right? And you reverse it, it becomes 0 1, right? So they are saying find all the sum from 10 to 0 1, right? So what will be the sum? The sum will be 17 minus 0, which is 17, right? So if we look at this, the answer is 17, right? So I hope the problem, how we did, I think you should do that as well, so that you don't get confused. So ending point was p sum of 10 minus initial point was 1, means you will say 1 minus 1, which is p sum of 0, and you will store the p sum of 0 as 0 itself, because there is no element. So we'll say, okay, I will store it as 0, right? So p sum of 10, which is 17, minus 0, which is 17. right? So I hope it makes sense to you, right? So this was the solution. Let's look at the code quickly, right? So what I did, I created a prime sector which is of size 1001, because at most they were, the problem statement said that you will have n as 1000, right? So 1000 numbers are there. Now I did a sieve, right? Sieve of parenthesis. If you don't know, wait till the end. I will explain in the end part of the video, right? So what I did is created a vector bool, right? I said 0 is not a prime, 1 is not a prime. We started from 2 and did the sieve of parenthesis. If you have doubt in this, wait, sorry for that, right? So what we are doing, we are simply marking all the prime numbers, right? The elements which are prime, we are marking them, right? And after this, what we are doing is we go from 2 to 1000. If it is a prime, I will say primes of I equal to I, else primes of I is equal to 0, right? After this, we can create a prime sum. What does this mean? Let's say I was standing at 2, right? Let's say I had a prime vector, right? So initially 2, I said, okay, mark this as 2, right? We came to 3, mark this as 3. We came to 4, it is not a prime. So what we will do, we will simply say if it is not a prime, mark it as 0. We go to 5, it is a prime, mark it as 5. Now see, this was my primes vector, right? This gave me a primes vector. Now let's find the prime sum vector, right? How will you find the prime sum vector? Let's say it was 2, so we will say in the sum will be this plus back value is 0, right? So 0 plus 2 will be 2. For 3, 3 plus 2 will be 5. For 4, 0 plus 5 will be 5. For 5, 5 plus 5 will be 10. See, the same exact sum we are repeating here, right? So that is what we are doing here. We are trying going from 2 till 1000, and prime sum of I will be prime sum of I minus 1 plus prime sum of I. So we created the prime sum, right? After that, we call this sieve to create a vector, right? And after that, what we are doing is we are simply we are creating the string s, right? Reversing it, right? Making it back into the integer, string to integer. And after that, I have the starting point. What will be the starting point? It will be minimum of the reverse number at n, and ending point will be maximum of those, and we can simply return the sum, right? So I hope this problem made sense to you. We are finding every query in big of 1 and sieve of parenthesis text big of and log n. So now quickly make me let me make you run through the sieve part, right? So how does this sieve work? You start with 2, you know 2 is a prime number, so you will go on all its factors, right? So j is equal to 2 into 2, which is 4, right? And then you do j equal to j plus I, which is 2 plus 2, 4. Then 4 into 4, 16, right? You mark that again as false, that number is not a prime number, right? Again you do j plus equal to 2, means 6. You go to 6, you mark that as prime, and you go on, keep doing this until you reach 1000, right? So in this way, C works, right? So ultimately, the time complexity is big of n log of n of C, and this is big of 1, right? So I hope I made sense to you. If yes, please do subscribe, like the channel, and if you have any doubt, do drop in the comments. I will be helping you out. Thank you for watching. And yes, I am also going to create a Discord channel, so stay tuned for that. I'm taking some time because I want to have some clarity on things that should be done on it. So after that, I will be doing it. Right? Thanks for watching.